So let's get right to it. So today's topic of the day is transformations of linear functions. And we're going to talk about what that means in just a second. So let's just do a little bit of an exploration. I want to know what exactly is a transformation. So what I want to do is I have these three lines, and I'm actually going to give them names. So with function notation, another good thing about function notation is that it allows you to give it a different name to each line. So for example, I could call this one f of x. I could call my blue one g of x. And this purple one, I'll call it h of x. Now, that's not supposed to be a confusing thing. That's basically just telling you that they have different names. Just like my name is Miss Lopez, you have a different name than me. It's just a way to distinguish one line from the other.
So it could be random letters? Like
you can literally use any letter, but most likely you're going to see f of x, g of x, and h of x. Those are pretty common ones. So what I'm going to do is I want to compare two things about these lines. I want to compare the slope and the x-intercept. So while I start writing this down, start looking at those graphs and think about what is the slope and what is the x-intercept. So just start by looking. I don't want any answers yet.
We write that?
Yes. You can write it as we go through it. But for now, I just want you to kind of look at the graphs and see if you can figure out those values. And if anyone has any answers so far for any of these, you can go ahead and say it. So what are the slopes? What are the x-intercepts? Can anyone identify the x-intercept of the blue g of x?
-3.
-3, good. And we're looking right here. There's my x-intercept. What about the purple one, h of x?
2.
Good,
-2.
2. +2 though, because careful, we're not looking at the y-intercept. The y-intercept is -2, but I wanted to know the x-intercept, which is +2. And what about for the red graph, f of x?
0.
Good,
0.
0. It's on the origin, so it's 0. So they have different x-intercepts. What about the slope? Did anyone calculate the slope yet?
For fx, I think the slope is 1.
1, okay, that's good. Yeah, if you pick 2 points and you check out the slope, this went up 2 and then to the right by 2. And then, so that's 2 over 2, which is 1. So the slope of f of x is 1. What about g of x or h of x?
That's also 1.
Also 1, yeah. Notice this is also 2 over 2, which is also 1. What about h of x? Could go this way. What's my rise and my run here?
1.
That simplifies to 1, yeah. So I would have 2 and 2 again, which again simplifies to 1. So what is the same for all of these 3 lines?
The slope.
The slope.
Slope is the same. All right, so that's one thing to notice. And then with that information, I can say one more thing, which is there's a very special keyword that you guys will see every once in a while. But what can I say? Does anybody know the vocab word for when any line is exactly the same, like same direction as the other line? You might have seen it before. It starts with a P.
What did you say, Miss?
If you know the
Oh,
vocabulary
parallel
word.
lines.
Yeah, parallel lines. So these are parallel. Parallel lines have the same slope. Same slope. So anytime you have any lines that have the same slope, those are parallel lines.
So we could have saved all this by just looking at the line.
Well, yes, but you wouldn't have learned a very valuable lesson. So that's one thing. But then we can also notice the differences. So even though they have the same slope, what's different about each of them?
They have different x-interceptions.
Different x-intercepts, exactly. So this leads me to what is a transformation? So a transformation, and specifically now we're talking about a horizontal transformation, is where you take a function and you move it to the left or to the right. So in this case, I'm going to call f of x, I'm going to call that one the parent function. And we'll talk about that in a second, but basically the parent function is like the OG. It's like the normal one where you're starting. So if I'm starting from the red one, how far do you have to move to get to the blue one? How many units? If I want to travel from
-3.
Yeah. And why did you say -3?
So you go to the left.
Because you go to the left, exactly. So to get from red to blue, I would have to go 3 units to the left. 3 units to the left. So it's the same slope, right? So literally all you do is you take the red graph and you just bloop, transport it over to the left. What about to go from the red graph, from f of x, to the purple graph? How many units? Right, that would be 2 units to the right. 2 units to the right. So that's what a transformation is, okay? So a transformation is where you take the parent function, the OG, whatever it is, and you're going to move it to the right or to the left. And that the direction, or like how many units you move, has to do with what we're going to do in the next slide. So there's going to be a rule that tells you where to go. But for now, all you guys need to understand is that that's what a transformation is. You're just kind of shifting things to the left, shifting things to the right. Any questions so far?
So Miss, that's why they were the same as the x-intercept?
Kind of, yes. So the x-intercept, when you look at the x-intercept, that's going to tell you how many units you moved. That's why I told you guys to look at the x-intercept, because from that number, you're able to see how far you went. So let's try an example. Okay, so here, the parent function, f of x equals 2x minus 4, is graphed below. So here is my parent function. I'm going to label it. I'm going to make it red. This is my parent, which again is just your starting one. This is like the OG. Okay, use the function notation rule to graph the new function. What do you notice about that was supposed to say x-intercepts, not y. So what do you notice about the x-intercepts? Okay, so first I'm gonna look at what it's giving me. So the function for the parent function is f of x equals 2x minus 4. which tells me a couple of things. That tells me that what is the slope of this red function?
2,
2. What is the y-intercept?
4,
-4.
-4.
-4. Good. Okay. Now it wants me to make a new function, and that new function is going to be f of x plus 4. So this is kind of different. We haven't seen this before, but this is function notation. So usually with function notation, what you've seen, what we did in the bell ringer, is when you just plug in a number. Well, here what we're going to plug in is not just a number, but we're going to plug in wherever you see an x, we're going to plug in x plus 4. So let me explain what that means. I want you guys to copy this down. This goes in your notebook. So I'm going to take my parent function, and wherever I have an x, I'm plugging in x plus 4.
Wait, we're writing the one in black that you're writing right now.
So you're going to write these things down: the parent function, the new function, and then what I wrote underneath. Everything that I write down.
Okay.
So I have my new function, but I need to simplify it because I'm going to need to graph it on this coordinate plane. But I can't graph it unless it's in slope-intercept form. So what do I need to do to simplify this so that it looks like slope-intercept form?
Wait, Miss, I got a question.
Mm-hmm.
For the 4,
Mm-hmm.
what is that for? Like, where do you look to get the 4?
The new function. It told me.
Oh, okay.
It says use the function notation rule to graph the new function. So I have my parent function. Now I'm getting a new function. And what I did to get the new function is I plugged in x plus 4 into the parent function.
Oh, okay.
So notice the parent function is 2x minus 4. But my new function, I'm doing 2 times x plus 4 minus 4. So I'm just plugging in x plus 4. I know it looks a little confusing, but we're going to do a couple examples. So again, all I did was I plugged in x plus 4. But like I said before, now I need to simplify this because I need to turn this into slope-intercept form. I need it to look like y equals mx plus b. So what should I do to simplify?
Get rid of the parentheses.
Get rid of the parentheses, okay? So we're going to distribute. And when I distribute, I get 2x plus 8 minus 4. But it's still not exactly how I want it, so what else should I do?
Subtract 8 minus 4.
Yeah. And what's 8 minus 4?
4.
4. So I have 2x plus 4. This is my new function. And since I have a new function, I'm going to call this one g of x, just to make it different from the original.
Means is the G is the same thing as the y-axis?
G of x, that whole thing, g of x is the same thing as y. So this is like, usually you would write y equals 2x plus 4. It's the same thing, but the reason I have a g of x is because I want to make it different from the parent function. Just like your name is Melanie, my name is Miss Lopez, we have different names. The parent function is f of x, and the new function is g of x. They have different names. That's it. There's no other reason why I'm doing that.
Okay.
Okay, but now I know a couple of things about my new function. My new function, what's the slope?
So
2.
2. What's the y-intercept?
Positive 4.
Positive 4. So I need to graph this new function. So where do I start in order to graph? What's the first point I'm putting down?
The 4?
The 4. And specifically, this is 0, 4. So I put that point down. And then where do I go from there?
Two up and one to the right.
Good. And how did you get that?
Because it's the slope, so you put it over once. It's not a fraction.
Good. So you want to make it a fraction. 2 is the same as 2 over 1. Well, that just means I'm going 2 up and 1 to the right. So here we go. I go 2 up, 1 to the right, 2 up, 1 to the right, 2 up, 1 to the right. I just did it a couple of times to get a few points, and now I connect them all. There's my new function. So again, this is g of x.
It's kind of like what we did in the homework yesterday, right?
Yeah, it's a little, I graphed it the same way that you guys had to do it on Khan Academy, yeah. You start at the y-intercept, and then you use the slope to get to the next point. All right, so I did all this work. Now let's actually see what happened. How do I get from the parent function to the new function? How many units would I move?
This to the right.
Good. Ascanio has it not to the right, but 4 units to the left, because I'm starting from red. So if I start at red and I want to move over to the blue one, I would have to go 4 units to the left. So this
Miss,
is
oh, okay.
4 units to the left. Okay, so let's kind of summarize everything that just happened. And I'm going to summarize, I'm going to erase a couple of things down here just to make room. So when I did f of x plus 4, because remember, what did I do? I plugged in x plus 4 into my parent function. When I did that, the whole graph moved 4 units to the left. It moved 4 units to the left. That is my transformation. That is what I just did by kind of plugging in a number. I was able to move the whole graph 4 units to the left. Questions so far? We're going to do one more example. So do I have questions so far?
I'm confused. It looks the same.
Well, that's because what is the same between both of these graphs?
The slope.
Yeah, the slope is the same, but do they have the same y-intercept?
Yeah.
The same y-intercept.
Wait. I don't know.
What's the y-intercept of the red graph?
2.
Y-intercept
Oh, 4.
of the red graph?
No, I thought you were talking about the blue.
Oh, okay, yeah.
Yeah.
Of the blue, yeah, the blue is 4. What about the red?
-4.
-4. What about the x-intercept? For the red graph, the x-intercept is +2. What's the x-intercept of the blue graph?
-2.
-2. So are they the same?
Yes.
They have the same exact values?
No, because
No.
one is negative.
Right. So even though they have the same slope, they are parallel, but it's kind of like you took the red one and you moved it over. You pushed it over to the other side. So they do look very similar because they're parallel. They're parallel lines, but that doesn't mean they're the same. Because if they were the same, they would be right smack on top of each other. But they're not. They're moved over. Okay? Questions?
Yes.
Does that clarify that?
Mm-hmm.
Okay. All right. Let's do another one. So same thing here. I have the same parent function, but now I'm going to do a different transformation. So I still have the same starting place. This is my parent function f of x. Then it's the new function in this case. Now they want me to plug in x minus 5. X minus 5. I'm going to do the same exact approach. So I want you guys to write this down as well.
Wait, miss, so what you're doing is that you're kind of like putting what the new function says to the parent function?
Yes, exactly. I'm just doing what it tells me to do. This PowerPoint is telling me what to do. It's telling me,
So you're plugging it in, right?
right, it's telling me to plug in x minus 5 into the parent function. So I'm
Okay.
copying the parent function, but instead of x, I'm writing x minus 5. Everything else is still the same.
I feel like this whole thing is just about plugging in.
It is. That's exactly what's happening.
No, like every single thing we do, we always plug in everything in.
That's kind of like 80% of algebra is plugging things in. Okay. So I plugged in x minus 5, but now I need to simplify it just like I did before. All right, so let's go ahead. We're going to distribute. And this gives me 2x minus 10 minus 4. And when you simplify, what do you get?
Simplify what?
This equation.
2x minus 6.
Close, but not quite. Negative 10 minus 4.
6x?
Oh.
Ascanio's got it.
What y is?
2x minus 14. Because you're subtracting. Minus.
Oh, it's because you took
Oh, I always
the negative.
forget.
Yeah, because we're adding negatives here. Okay, so again, this is my new function. I already used, what did I use in the previous one? G of x? Okay, so here I'm going to make this one h of x. So h of x is 2x minus 14. Now let's compare. Let's talk about what we know about this function. We know, what's the slope?
2x.
2, just 2. And what's the y-intercept?
Negative.
Negative 14.
Negative 14, good. What was the slope of the original, the parent function?
2.
Also 2. And what was the y-intercept of the original?
Negative 4.
Negative 4. Okay, so what's changed so far? What do we know that's different? Y-intercept is
The
different.
y-intercept.
Good. All right, now I'm going to graph this, but I have a little bit of an issue, which is that this coordinate plane, it stops at 10. So I can't actually get down to the negative 14. So I'm going to cheat super quickly. I don't want you guys to get confused. Don't worry too much about what I'm doing right here. I don't want to confuse anyone, but I can't figure out where, I can't put the y-intercept down on this graph because it would go off the page. So instead I'm going to look for what happens at the 3. So I'm just going to quickly plug in a 3.
Oh, you're doing that?
Yeah. I'm just going to plug in a 3. 3 times 3 is 9. 9 minus 14 gives me negative 5? No. Is that right?
Yeah.
Yeah, that's right. Negative 5. Again, that was just Miss Lopez quickly doing something to help herself
Guys,
out.
I never learned about that table.
That's the thing, is like with anytime you have a function, if you need to see where it is on the graph, you just plug something in and see what you get. That's literally what I just did.
Oh.
Okay, but don't stress about it because that's not the point. Okay, so I know that this is one of the points on the graph, and now I'm going to use my slope to give me the next point. My slope tells me to go where? From here I go where?
4. Never mind.
It's the same slope as before. So what are my
14.
directions?
2 up and 1 to the right.
2 up and 1 to the right. Okay. 2 up, 1 to the right. 2 up, 1 to the right. 2 up, 1 to the right. Just doing it a couple of times. Okay. Hold on, I think I messed up somewhere. 1, 2, 3, 4, 5. Hold on, I messed up. Hold on. Scratch everything I just did. Give me 1 second, guys. 2 times 3. Oh, this was 2 times 3. So this was 6 minus 14. I don't know where I got 9 from. 6 minus 14 is -8. Okay. Sorry. Let me just finish up. Okay. This is where I want to be. And then I do 2 up, 1 to the right, 2 up, 1 to the right, 2 up, 1 to the right.
Why 2 up and 1 to the right if you have that 14 for B?
Because the 14 doesn't tell me where to go. Which one tells me where to go? What's telling me to go 2 up and 1 to the right?
The 2.
The 2, the slope. That's what slope is. That was your homework. If you are,
Oh, wait,
if you're
is
not
that
sure,
B the y-axis or not?
yeah, the B is the y-intercept. Guys, I've been doing this since last week. If you are
Y-intercept.
still unsure about slope, I invite you to go do the homework again and practice it again because I'm done teaching it. I already went over it all of this last week. Okay, this is my new function. It's called h of x. And let's look at what happened. How many units did my parent function move to get to the new function? Good, Daniela. 5 units to the right. So let's summarize. What I did was I had to do f of x minus 5. And what that did to my function, to the parent function, is it moved it 5 units to the right. Okay, so let's compare now. Going back 1 slide. This one was f of x plus 4,
Miss,
and that moved it, let me finish, and that moved it 4 units to the left. This one is f of x minus 5, and it moved it 5 units to the right. Now you can ask your questions.
Miss, you know what I noticed is for the for where the new function it says -5. It basically like changes the sign and it's +5, so you go to the right. And
Yeah.
it's like the same thing for the other one.
Yeah, so that's exactly what I wanted you to notice. Here, it says f of x minus 5, but what does it do? It moves it 5 units to the right. Whereas over here, this was x plus 4, and it moved it 4 units to the left. So it switches it around, kind of. It's kind of the opposite of what you think it's going to do. So what we can do with this information is I'm going to I have a general rule, and I want you guys to write this. Actually, you don't need to write it down right now because we're going to summarize it at the end. But basically, if you take a number, any number, and you add it to your function, so if you have f of x plus any number, that's going to shift the graph k units to, so if I'm adding, what was the pattern? If I'm adding a number, is it going to the left or to the right?
To the right.
Left.
To the left.
Yeah.
It's the opposite, yeah. But then when I subtract a number, that's going to move it to the
Right.
Right?
to the right, exactly. And that's going to happen no matter what number you choose. So here's some examples. I don't have a graph anymore because now I can just quickly use this rule. I don't have to do all that work. I can just follow the rule. So in this case, if I have f of x plus 6, I know that I'm moving where?
The right.
To the left.
To the left. How many units?
6.
6.
6 units. If I have f of x minus 3, this is telling me that I'm moving to the
Right 3 units.
right 3 units. F of x minus 5 means I'm moving to the
Right 5 units.
right 5 units. So all that work, units. Oh my gosh, I can't spell. Units. Okay. So all that work that I did here where I had to plug it in and I had to distribute and I had to figure out the new equation and then I had to graph the new equation and then that was a lot of work, right? You can skip all those steps just by following this rule. Because now I know all I'm doing is I'm taking whichever function I started with and I'm just moving it over to the left or to the right. I'm not changing the slope. I'm not changing anything else. It's just moving. Do I have any questions so far? Okay. Like I said, you don't need to write this down right now because I have another slide later on where you guys will be able to copy everything down. So for now, you don't need to write it, but you will later. Okay. So that was that was horizontal transformations. Now let's think about vertical transformations. Vertical transformations is when you go up and down, because vertical means up and down. So let's take a look at these two lines. I'll call this one, I'll name them two. This will be f of x. And then the light blue one will be g of x. And start looking, start thinking, start figuring out what is the slope and what is the y-intercept. What is the slope? What is the y-intercept? So can anyone identify for me the y-intercept of f of x?
1.
Good. For f of x, the y-intercept's 1, right here. What about for g of x?
7.
Good, 7. And what about the slope? Do they, first of all, before you even calculate it, do they have the same slope or a different slope?
The different.
Ooh, so someone said, a couple of people are saying same in the
Actually,
chat.
same.
Yeah, what can you always look and try to see if you can try and see if these are parallel? Are they parallel?
Yes.
They are.
Yes.
So we know they're the same slope, but now let's actually calculate it. So with g of x, I can pick 2 points and figure out the rise and the run. So you guys try it out. What's the rise? What's the run?
3/2.
Almost. Since my run is going down.
1/3.
Yeah. Since my run is going down, it would be -3/2. And then the same thing for f of x. Even though I can tell already that they're parallel, I'm just going to check. So this goes down by 3, and then 2 to the right. So same thing, I get -3/2. So same slope, but the y-intercept is different. So what we can think about in this case is how do I go from f of x up to g of x? How many units would I have to go up?
6.
Good, 6 units up. Since the slopes are the same, all I would need to do is take my f of x and just slide it, like push it up, and it would be able to match up perfectly with g of x. So that's what a vertical transformation is. Vertical transformation is where you just push up or down. You're going to shift it up or shift it
Oh.
down.
So it's the same.
You're not moving it to the side, right?
So it's kind of the same thing. It's just a different way of looking at it, because you can also say that this is moving a few, I don't know, like a little bit less than 4 units to the right. You can say it both ways, but we're going to focus right now on vertical. So instead of looking at the x-intercepts, we're going to look at the y-intercepts now.
Thing is that the y-intercept is more exact than the
Yeah.
x, because we don't really know how much it really is, like how many units it really is.
Right, yeah. Like right here, I don't really know where that is, and I also don't really know where that one is for the x-intercepts. So it's going to be easier to look at the y-intercepts, Melanie, exactly. Okay, so let's do it. I have the same parent function. I'm not changing that because I want you guys to be able to see all the differences. So I have the same parent function, but take a look at what they want me to do with the new function. What is different here?
Add 4.
We're adding 4. And how is that different than, let me go back really quickly. How is that different than this one? So look at this
Because
one.
before we were subtracting.
Here we were still adding, but I want you to pay
They
close
don't
attention.
want you to X.
The x.
Yeah, so pay close attention to where that 4 is located. Here, this
It's
is
in the parentheses.
in the parentheses, but over here, where is it?
It's outside.
It's outside. So what this is telling me is that I'm not going to plug in 4, but instead I'm just going to add 4 at the end. So I'm not plugging it in, but instead I'm just going to add it to the end. So I have my parent function, and then for my new function, sorry, f of x plus 4, I'm going to take the old one, 2x minus 4, and all I'm going to do is I'm just going to add 4 to the end of it. That's all. So again, I'm not plugging it in this time. There's no parentheses. I'm just adding it at the end. It's kind of easier, actually. And what does that end up being when you simplify? What do I end up with?
2x.
Yeah, just 2x, because what happens? What's negative 4 plus 4?
0.
0. So this is just 2x. So my new function, okay, I used f of x, I've used g of x, I used h of x. Let's call this m of x, because m is the best letter in the alphabet.
That's me.
So m of x is 2x. What does that mean about the slope? What's the slope?
2 over 1.
2 or 2 over 1. And what's the y-intercept?
0.
Good, Antonio, nice job. Yeah, it's 0. Because there's nothing there, so it's just 0. So now I can graph this. I'm going to start at the origin at my 0. And then I go up 2 over 1, up 2 over 1, up 2 over 1. And I connect everything. Oops, hold it. Let me fix that. Cool. So here's my graph. And let's talk about the similarities and the differences. So what ended up being the same from the old one to the new one?
The slope.
Slope is still the same. What about the y-intercepts?
Different.
Yeah, they're different. If I'm talking about vertical shift, so I'm shifting it up or down, what happens if you want to go from the red one to the purple one? From f of x to g of x. Or sorry, m of x.
You said purple to red.
Red to purple.
You go back 1, left 1.
You would if you were talking about horizontal shift, but I'm talking
Okay.
about vertical.
I'm
What?
lost now.
How do I get from red to purple? Talking about vertical shift. Up
What are
and
we
down.
for?
That means we're looking at the y-axis.
Look at the y-axis. Look at the y-intercept.
-4?
Close. I'm going from
4.
red
4.
up. Yeah,
I
up.
said 4, miss, like 3 times.
Oh, I didn't hear it. I'm sorry. So the red graph goes up 4 units to get to the purple one. So to summarize, f of x plus 4 results in going up 4 units. Up 4 units. So think about what that means about the pattern, about this type of rule for vertical shift. So if I'm adding 4, that's telling me to go up 4.
So it stays the same, basically.
What do you mean it stays the same?
Like, it's +4, so it's still going to be +4, not negative. Like,
Right, yeah, so plus means up. Yeah, so that doesn't.
this other one was switching.
So what do you think is going to happen in this case? So here, I have the same parent function, but what is it telling me to do now?
I think we're gonna go down.
Down, yeah. It looks like we're going to need to go down.
Oh, since we have that negative sign.
Exactly. So let's
Let
take a
me write
look.
that down.
We're going to do in the next slide, it's going to be a big summary. So I know you want to write it down, but you'll get the opportunity in just a minute. Okay, so f of x minus 4. Now I'm going to take f of x and I'm going to subtract 4 at the end. Because again, I'm not plugging it in this time. I'm just
So we're
adding.
subtracting it since it's not in the parentheses.
Yeah, it's not in the parentheses, so we're just subtracting. So what is -4? And here it is again, 2 negatives. So we're in your head, you're going to add those numbers. What's -4 minus 4?
-8.
-8. Good. So this is 2x minus.
-8.
All right, and I'm going to call this one. Let's see, what letter should I use?
J.
Obviously.
Okay, I'm going to go with J because
AJ.
J is almost like an I, and I heard both of them.
Nice job, miss.
J of x. So J of x is 2x minus 8. What's the slope?
2.
That hasn't changed at all. What's the y-intercept?
-8.
Good, -8. So let's, again, I'm graphing this now. Goes back to what you guys had to do for homework. Where is my starting point if I'm graphing it?
-8.
-8, good. 0, -8. Now from there, where do I go?
2 up.
2 up. Good. 2 up, 1 to the right. Because the slope is 2, so that's 2 up, 1 to the right. 2 up, 1 to the right. Okay. There's my new function. There's J of x. And let's talk about vertical shift. If I want to go from the red one to the orange one, how many units would I need to go and in what direction?
You go down 4. I think.
Yeah, down 4 units.
Miss, it took me a while to understand, but now I do.
That's the thing with this class. A lot of times things just are going to be fuzzy until it just clicks. So at a certain point, things always click.
Miss, I got an A and a B yesterday.
On the homework? Nice.
Yeah.
Love that.
But you don't know how much I had to try.
That's good. The more work you put in, the better the results are going to be. Okay, so to summarize here, if I do f of x minus 4, but the minus 4 is outside of the parentheses, that's telling me to go down 4 units. Questions so far. So I'm going to take us all through everything we've done so far. Ready? Quick summary. F of x plus 4, where it's inside the parentheses, moved me 4 units to the left. F of x minus 5, where x minus 5 was inside the parentheses, was 5 units to the right. f of x plus 4, but now we're outside of the parentheses, was 4 units up. And f of x minus 4, where it's outside the parentheses, was 4 units down. So let's do a quick summary. If I'm adding a number, k, any number, and it's outside of the parentheses, where am I going? This will shift the graph of the function k units where? Up, down, left, or right?
Up.
Good, this one's up. F of x minus k will shift the graph of the function k units
Down.
down. And like I said, now that we know this, we don't need to do all the work because we can just look at the rule and figure out right away where it's going to go. So in this, for option A, example A, where am I moving and how many units?
Up.
Up.
Okay, so when it's not like in the parentheses, that means it's either going up or down.
Exactly. That's a vertical shift, up or down. So since the 4 is outside of the parentheses, that's up. This 3 is outside the parentheses, so that's going where?
Down.
Down. What about this last one?
Left.
Not quite.
No, right.
Right. Yeah, this would be 3 units to the right. Because remember, when it's inside the parentheses, it's the opposite. Okay. Questions so far? We just did a lot. Do I have any questions?
Yeah, for C, isn't the 3 considered negative?
For B?
For C.
For C. Yes, that 3 is considered negative, but the rule says that when it's inside the parentheses, it goes the opposite way of what you're thinking. So even though it's negative, and to me negative says to go to the left, I have to remember that that's going to be the opposite, so I'm going to the right. That's the tricky part, but that's something that you can memorize pretty easily and just try and remember.
All right, thank you.
Okay. We're going to do 2 more examples. These are a little bit different, but we're still talking about the same thing.
Hell no, miss. What is that?
It's amazing. Don't worry. Let's take a
Miss,
look.
where's the part where we write it down?
This you're not going to write down yet. You're going to see. It's coming up.
Oh.
Okay. I'm going to go through this a little bit quickly because this is not on the test so much, but I still want you to see what it means, okay? So this is why I'm doing it. So I have a blue, I have a green, and I have a red. Which of these is the most steep? Which one's the steepest? Which hill is going to be hardest to climb?
The red one.
Red.
Red, right? The steepest is the red. Which one is the easiest, the least steep?
The green.
The green.
Good. Okay. I want you to look at the equation for these 3 graphs. So for blue, it's just y equals x. For red, it's y equals 3x, and I'm rewriting it because it's a little bit fuzzy. I just want to make it clear. And for the green one, I'm going to write it over here. This is y equals, they put 0.25x, but I'm going to put it as a fraction. So 1/4 x. So notice, which of those has the biggest slope?
The red.
The red, because that's a 3. Which one has the smallest slope?
Green.
Green. It's 1/4. 1/4 is smaller than 3. And then for the blue graph, the slope of the blue graph is just a 1, because we know there's an invisible 1. Again, I'm going to go through this a little quickly. I do not want you guys to, I just want you guys to follow along. Just watch. You don't have to copy anything. You're just going to watch. This is my parent function, f of x. this new function, it is telling me to take f of x and multiply it by 2. This is telling me to do 2 times f of x. So that's what I'm going to do. I'm going to take f of x and I'm going to multiply it by 2. So I would take my 2 and I'm going to put everything else in parentheses because I'm just going to multiply everything. And when I do that, I end up with 4x minus 8. And let's call this one b of x. 4x minus 8. So my slope is 4. My y-intercept is negative 8. In the parent function, which is the same one we've been using, the slope was 2, and the y-intercept was negative 4. So what happened to the slopes? Are they the same anymore?
No.
No, it went from
Oh
being,
no.
yeah, it went from being 2 to now it's 4. So which one is going to be steeper, the red graph or the orange graph?
Orange?
The orange.
Yeah, so let's take a look. I'm going to graph it. Oops. I start at negative 8. And now my slope is telling me to go 4 units up and 1 to the right. So I'm going to go 1, 2, 3, 4, and then 1 to the right. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right. Okay, there's my graph. And just like we predicted, that orange graph is much steeper, much more steep than the other one. So when I do 2 times f of x, and this is why I don't want you guys to worry too much, because I'm not talking about y-intercept. I don't really care about that right now. All I'm noticing is that it becomes more steep.
That's when you're multiplying this?
When you multiply it, yeah. So when you multiply it, it becomes more steep. Questions on that? All I did was multiply it and it just became more steep. That's all it is.
No.
All right. Now in this case, I'm not going to multiply, I'm actually dividing, because remember, fractions are like, yeah, fractions are basically like division. So let's take a look at what happens in this case. And like I said before, I'm moving a little bit fast, but that's because I don't want you guys to over stress about this, because this is meant to be a little bit easier. So here's my parent. Okay. And I am multiplying everything by 1/2. 1/2 times f of x. So I'm going to take my 1/2 and multiply everything by 1/2. But remember that fractions are like division. So you can think about it as multiplying by 1/2. You can also just think about it like you're dividing everything by 2. So what is 2 divided by 2?
1.
1. What is 4 divided by 2?
2.
2. Good. So this is my final, this is the last one we're doing. I promise, this is it. And I don't know, what letter have I not used? Someone give me a letter.
A.
A? Okay. So a of x is 1x minus 2. My slope is 1. And my y-intercept is negative 2. So I go to the negative 2, and I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Do it a couple times. There it is. So what ended up happening? Is it more steep or
It
less?
got less steep.
It's less steep.
Less
red.
steep. Good. So 1/2. When you multiply it by a fraction, because fractions are basically like dividing.
So when you divide, it's less steep, but then when
It's
you
less
multiply, it's more steep.
Exactly. That's it. That's why I wanted to go through this a little bit quicker because this one's kind of easy. When you multiply by a number, it becomes more steep. When you divide by a number, or you can think about it by when you multiply by a fraction, it goes less steep. So now, like I said, oh, let me just fill in my blanks. So when I multiply, it becomes more steep. When I divide, it's less steep. That's all you got to know. So for A, what would that be? More or less?
More.
More steep. What about for B?
Less.
Less.
Less steep. And C is kind of putting two things together. So what's happening in C?
More and more and up, I think.
Good. And 2 units up. Perfect, guys. Good job. So it's really just about reading function notation and knowing what it's telling you to do. And now the moment everyone's been waiting for.
Finally.
Finally, I have all of the rules in one table and I want everybody to write this down. Don't take a picture, don't take a screenshot, write this down. Because guys, the more you write things down, the better. First of all, the easier it is to memorize. And second of all, anytime you have a homework assignment or maybe a quiz, if I let you have notes in front of you, you can always come back to this and you'll know the
But
answer.
you have to give us time, miss, to write it.
I am giving you plenty of time. I'm going to start with about 5 minutes and then you guys tell me if you need more time than that. I should see pencils writing. I see lots of hands not on pencils in that classroom over there. I can see what you guys are doing and I can see who's not writing. Okay, about 1 more minute left of your 5 minutes. Let me know if anyone still needs a little more time than that.
Yes, miss, we need more time.
Okay. Way more. Okay. All right.
Lopez?
Yes.
Oh, Miss Lopez, you have Mark. He didn't do no work all class. You have Wesley, right? Wesley didn't do no work. What's your name, sir? Huh? JC didn't do no work in class. They just sitting here chilling.
Have they been writing down? I know JC answered a couple of questions in the chat,
Who's JC?
but
Like he was all like, I don't know. That's
Yeah.
do no work. He got a blank sheet of paper. Ain't got nothing on it.
you have nothing on that, Wensley?
Nope.
Nothing.
Nah.
And how is that going to help you in your test? How's that going to help you pass this class, which you need in order to pass high school, huh?
They don't want to pass.
Some of y'all not understanding that if you don't pass this class, you're going to have to repeat it and you cannot graduate from high school until you pass algebra.
Cool. You got eighth grade again? Huh? Come on, man. You gotta make an effort. You didn't write nothing at all. At least he kind of wrote something. He didn't write nothing. Mark didn't write nothing back there either. Just make sure you show your parents. That's why you came to school today.
All right, how much more time do people need, guys? I want to do one test question at least.
Like 3 or 2.
3 more minutes? Girl, it's been like 7 minutes. Y'all still need more?
Miss, that's a lot, miss. At
Okay.
least I'm writing it.
Yes, I know you're writing.
I still need stretch and comprehension.
Compression. Okay. My goal is to do
Question.
one question. I want to do one challenge question so that you guys can see what this looks like on a test. So the faster you write, the faster we can get there.
Next class, you're not gonna write nothing. You don't bring your computer charge. Your pants are saggy. I don't want you. You heard me?
Miss, I'm done.
Okay, Melody's done. Who else? How much? If you're still writing, tell me in the chat, how many more minutes do you need?
What my man said. Man, never mind.
2 more minutes? Okay, I can do 2 more minutes and that's it.
Miss, you could have just put horizontal, left to right, and like that.
What do you mean?
Never mind.
All right, 1 more minute left. 1 more minute left. Finish up. Thirty seconds. Good. Andy's done. Who else is done? Zaria's done. Elvis is done. Alyssa's done. Lori Hayden. Good. Most people seem to be done. Okay. I'm going to do one test question and then we'll be out of here, okay? Let me pick a good one because I have a few.
Miss, you got 2 minutes.
I know. Here we go. Here's a good one. Here's literally, this was from last year's test. So maybe it'll come back because sometimes they love to reuse questions.
Let me save it.
Okay. Which of these equations describes the function g of x in terms of the function f of x? So take a look at what type of transformation is happening. Is it going up? Is it going down? Is it going left? Is it going right? And then try and see which one it matches. I'll give you guys 1 minute, then I will review the answer and then we'll be done. 1 minute to think about it.
This is way more different.
So think of your answer in your head. You can also send it to me privately. I'll tell you if you're right. Ten seconds left.
Good afternoon, Jaguars. At this time, we're going to begin our dismissal procedure.
All right,
to the third floor.
that's time.
Dismissal at this
All right,
time.
so to go from f of x to g of x, there's two possibilities. You can either go up 2 units or to the left 2 units. But what the only answer choice that gives me the correct possibility is answer choice C, because this one says to go up 2. Answer choice D is wrong because this was down. B is wrong because this is to the right. No, this would be up 6, my bad.
Staff and students, as a reminder, following up this uniform policy, Friday is a regular uniform day.
And what was A?
Classes will be allowed on campus. Thank you.
Real quick, what would A be? What type of transformation?
More steep, I think.
Yeah, more steep, which it's not. So C was correct. Good job to those who got it. As a reminder, okay, there's no homework tonight, but if you had any old assignments you haven't done yet, go back and get them done so that I can put that into the grade book. Okay, that's all for today. I'll see you guys tomorrow.
Bye,
Hey,
Miss.
Mom. The good thing there's not any homework because I don't think you understood anything from this.
Okay, make sure if you're lost, you can rewatch this video. I'll post it as soon as class is over.
Okay.
Khan
I got like a
Academy video.
75 on one, and then I think it was from the linear one. I got a 75.